And welcome back. Now today we're going to talk about a different board altogether. Now normally you probably know that I use the Arduino Nano for most of my projects purely because of its size and of course its cost as well. You can probably buy a Nano for about £2, but this little board here is half that price and indeed half its size. But is it worthwhile actually using in one of your projects? Because price is not always everything, is it? You have to consider ease of use. Well, there are some caveats to be had with this particular board, but for simple projects that don't require many GPIOs, this could be an alternative. And given that it costs about £1, just over the pound mark, about $1.30, and here we have a quarter for our American viewers, just to get you the size implication, and here's the euro for our European brethren. You can see exactly how small it is. Now, size, yes, can be a factor when you're creating a project, but also ease of use. Now you can see down here at the bottom edge it's got P0 to P5, so you think, oh well, that's 6 I/O pins maybe. Well, not quite. We'll talk about that in a minute. And over this side, of course, you've got the 5 volts, the ground, and the V in. But best of all, and the reason why I bought it was because it had a USB socket on it, which is one of the reasons why I won't use any of those Arduino Pro Micros that do not have a USB socket on, because it's just too much faffing about having to put an FTDI programmer on it every time. I want ease of use. So when I create something, I want it to be easy to use, not faffing about. So I thought, right, well, this is okay. It's got a USB port. Let's have a go and see what it can do. I only spotted it really because I was browsing the internet as one does, seeing what was available, and this one popped up. So let's have a look where I got this from and where you might be able to get it from as well. And then we'll talk about what this can actually do and the limitations which you have to be aware of if you're going to buy one of these and put it into one of your other projects. That said, don't discount this straight away and thinking, well, it's a toy, isn't it? It's nothing like an Arduino UNO or a Nano. Well, that's not true. This supports SPI, I2C, it's got GPIO pins, it's even got an analog pin. It's got some stuff going for it. You just have to be aware that in a chip that's only got 8 pins in total, 2 of which are used for the power supply, there are some constraints you have to work within. But that said, it's worth looking at. So let's have a look to see where I bought this from and where you might be able to get it from too. So here we are. This is where I bought it from. Who is it? Tiny85, but I mean, you know, there are plenty of sellers selling it, and this is the UK site, but this is a Chinese seller, so he'll probably be on eBay.com almost certainly. And £1.18. Now, for the price, you think, hang on, I'm actually getting a programmable microcontroller for £1.18, and for simple projects it could be all you need. If you cast your mind back a few videos ago, well, quite a few videos ago now, when I was doing my fridge alarm, this might well have been just about enough. That said, the reason I replaced my original fridge alarm, which was run using a microchip microcontroller, so it was in fact the 08M2, which was a powerful chip in its own right, but it just didn't have enough GPIO ports for me. So I had to abandon that idea and I put a Nano in, and then of course I had ports coming out of my ears. I had far too many effectively, but it was only £2. It's actually cheaper than an 08M2 board. So the Arduino world certainly does make things cheap. And this one too is cheap. I mean, £1.18, what's that? Just over the pound, so let's say $1.50, something like that, and probably about the same in euros, I think. Okay, let's have a look where else we can get it from. So just scanning the sort of eBay sites, I looked for AT Tiny85, and well, the cheapest it did bring up was this one here, KN35, probably why I went with him. But there's a fair few here. Look, this one here, 1, 2, 5 and 10 pieces. So if you bought 10 from this chappy here, module me, £9.89, so that's less than a pound, 98 pence a piece. And as I say, for those little tiny projects, that might be all you need. Okay, so if it's that great then, what is it you can do with it? Right, let's have a little demo first. I've written a couple of little sketches just to prove that it actually hangs together, and we'll see what effect some of the GPIO pin connections might have when you come to use it. Okay, that's coming up next. Right, so what I've got here on this board is an AT Tiny85 connected up to a little circuit here. Ignore this one at the back. Well, sort of ignore it. This is an UNO clone doing something else over here with infrared, which is a totally different project. But I did eventually use this Arduino at the back here to power this board because of some unexpected issues I was having when powering it from the USB. But we'll come on to those. Now, also, I said in conjunction with the size, I said, look, here's a nano. This is one in the middle. So this nano is connected at the moment to a development board, which if you're going to use a nano for development, you certainly want a board like this. So you've got a few more pins and inputs and outputs and things like this. Very nice little board, actually. You can buy these on the internet. They're probably only about £2 or £3. Right, so this is a nano. And as you can see, an AT Tiny85 is what? Half the size and half the price. But I do believe it's probably less than half the capability, given this is a fully fledged AT Mega 328P, and this one's an AT Tiny85. We'll have to see about that. But in the meantime, let's plug it in and get something running just to prove that it actually does work and understands the Arduino code, because there's a couple of things you have to do to get that board recognized. Not difficult, but you do just have to follow some introductory sort of articles which people have put together. Okay, right, what we're going to do then is connect this up, run the equivalent of a blink program, and when I got this, as soon as I powered it up instantly, it did blink a little LED, same as most nanos and Arduinos you get it, that has the blink program loaded. So I've modified it to blink a bit faster, a double blink, just to prove it works. And not only that, I've connected up this board here with a much larger LED so you can see the double blink. Ignore the resistors and all that, that's just a little bit of logic on the code which we'll come on to. Right, let me connect this up and I'll be right back. So here's the AT Tiny85 running with the slightly modified blink program. As you can see, it's blinking both on the board, so it's way back, where's it gone? There. So that's the double blink. It does have an LED built on, but it's not on pin 13. All right, we'll come on to that. And all I'm doing is replicating it out here, really, by turning one of the GPIO pins on and supplying a bit of current to this. And that's it. Well, apart from a little bit of business logic, just to prove that one of the other GPIO pins could be used as an input, if I disconnect this orange wire here, which is currently connected to ground, if I take that off, it all stops, because the logic says only when this is low will you do the blink. Okay, off, on, off, on. Okay, great, I thought. At least it understands the Arduino code. So let's have a look at that now. Right, so this is, as you can see, a really ultra complex bit of code. Yes, now, interestingly enough, the example I was following, I can't remember where it's from, whether it's from Arduino themselves or somewhere else, but basically, depending on the model you've got, the LED may be on pin 0 or pin 1. So if we look at this one that isn't connected on here, no, it's too small. Let's go back to full screen. Right, so if we look at this one here, you can see that the pins are numbered P0 to P5 along the bottom. All right, now they don't correspond to any of the pins necessarily on here, although there is a circuit diagram I'll show you a bit later. So on some modules then, depending on which module you have exactly, it's either the LED is on pin 0 or pin P1. Logically speaking, that is, it doesn't mean pin 1. Okay, and I didn't know which model of module I had, but I just tried them both out, and it was in fact pin 1 mine worked with. So mine is obviously a Model A or a Pro. I don't know what a Pro is. Is there a Pro AT Tiny85? I don't think so. Anyway, it works. So all I'm saying is here, remember when I disconnected that why it all stopped running, because all I'm saying is read the input from pin 2, which I've said is an input, and only if it is low then do this double blink. Now I did initially have this as an input pull-up, but then I had a few issues and I thought, well, does it actually support input pull-up? Now I'd have hoped that the compiler would have complained if it hadn't, but I changed it to an input anyway, and then on this circuit I actually put a pull-up resistor on it. But as it happened, it was nothing to do with that. It was the fact I was using the wrong, quotes unquote, pin for that. So on this unit here, P6 is in fact a reset pin. It says it can be used as a weak GPIO pin, which I've yet to discover what that means really. But it says anything longer than a minuscule fraction of time bringing this low will in fact reset the pin, the whole unit. So that's why it didn't work. So you can indeed use input pull-ups here. But the first question is, how does it know that what I'm writing to here is in fact an AT Tiny85 and not a UNO or something? So what we have to do, in order to get this recognized, we have to say in preferences, that's file preferences, this bit, additional boards manager URL, click this little thing on the side here and add in this URL. Don't worry, that'll be on the video specification or description at the bottom of this video. Add that in, OK it, and if you're OK again. Now if you're not using at least 1.66, you see this is 1.612 now. If you're not using 1.66, you'll have to shut down the Arduino IDE and reopen it for it to recognize that. But I was using 1.612, it's absolutely fine. Just a little word on that. The reason I was using, what was I using? I think it was 1.65. In fact, I reverted to 1.65 because 1.66 and or 6, 7, 8, 9, 10, and possibly even 11 had a bit of an issue. There were some bugs in it basically. It was all over the internet forum, especially the Arduino forum. And they said, when you hit those bugs, there's nothing you can do about them really. You have to rather revert or use a different IDE. Now normally I do use a different IDE, so I didn't really have a lot of issues. But I still reverted to 1.65. But I noticed just a day or so ago, the 1.612 was out, and apparently that's not had any negative feedback. So 1.612 is a good one to go to. Anyway, so having added that into the preferences, we can now go to Tools, Board. Now you see here it says Genuine UNO because that's what I was using a minute ago. Go to Boards Manager. It says here All, but we'll just give this a second to refresh itself. There we are. So now we can click that and say Contributed. So these are boards that they're made by third parties, I suppose, and they're contributing a lot of stuff. So not Windows, it's this one here, Digistump AVR boards by Digistump. Now why Digistump, you may ask? Because they're the ones who've written the bootloader for that AT Tiny85. They've written the bootloader and it's already loaded, it's preloaded. When you buy these modules, it's almost certainly preloaded, otherwise they couldn't get anything on them. Obviously, yes, you can program these without a bootloader. You can use an Arduino to program these. But remember what I said at the beginning of this video, it all gets a bit cack-handed, I find that. And it's just too long-winded. I'm here to build stuff, not to faff about with the components within it. So by using that particular board definition and the bootloader already in here, you can use the USB port. Not quite the same as the standard UNO, but we'll come on to that as well. So anyway, you can see I've got 1.67 installed. If I hadn't got it installed, this wouldn't say remove, it would say install. So that's what you do, install that, it runs. Slight caveat on that, while it was running, I did get an error, well, more of a warning really, saying, oh, I couldn't run a particular item. Now, what you have to do is follow 3 steps. I'm going to describe these in more detail in the video specification rather than on screen because it all gets a bit confusing. But if we go back to the browser window, there are 3 things on here you need to be aware of. Let me just shut that one down. Right, first of all, here's the Atmel Tiny, it's the 85 one we're interested in. It's the specification sheet and it just tells you everything it can do really, and good reading it is. But it runs on 5 volts, it can do SPI and I2C, but within software, it hasn't got hardware support for those, and a few other bits and pieces. It's only got 8K memory, so that's a bit different to your 32K of your Arduino UNO or Nano, and 2K of that is taken up by the bootloader. So, you know, there are some restrictions. Oh yes, SRAM is also limited. I think the one I have, it's got 512 bytes SRAM, not the 2K that the UNO has. So as I say, there are limitations, but it depends on what you're doing with this. Yes, you can't send a man to the moon on this particular one, but you can probably run a fridge alarm or something simpler like that on it. Anyway, that wasn't the one I really meant to show you. Let's go back to here. Now here's a web page which, quite frankly, I wish I'd found before I did all the hard work, because it tells you everything you need to know in here. Let me move this one into full screen mode. So this, I'll put this URL in the description as well. This talks about this AT Tiny85, and this is exactly the model that I showed you on eBay and the ones I bought. So follow the instructions in here. It tells you about this micro nucleus Tiny85 bootloader. It's made by well, the chaps that say Digistump. They I know, support or run Digistump. So you need to go to, this is connecting and programming. It's called a Digispark because this board, I'm guessing, was originally manufactured by Digispark and then it was cloned by our Chinese friends. But effectively it's a Digispark board, AT Tiny85. Okay, so when it says Digispark, just assume it's one of these. So it runs this bootloader, and you must, it says here, look, use IDE 1.65 onwards, but not 166 or 167. That's because of those little bugs I told you about. So the first thing you've got to do is download the, well, that's the actual Arduino package itself. Then the drivers, so download this, extract them, install them. They don't fully install. There's one I got an error on. It didn't seem to make any difference though. Then we go through the issue, well, the step that I said about adding to the boards. Look, there we are, that's no problem at all, and clicking on the Digistump thing. Then we choose the Digispark default 16.5 megahertz, and that runs absolutely fine. One little thing it says about here, if you didn't get a Digi USB, well, I didn't, I still haven't, it still works, so maybe it's because I'm running Windows 10, maybe. So I hope it doesn't ever show up as USB connection on my system, don't know why. Still works though, as I say. Now this is the thing, when we've installed those extra boards from Digistump, as it tells you to do that here, it says here, when complete, the install will pop up, blah, blah, blah. You can read all this as well as I can, but basically it's supposed to install or update the drivers at that point. Well, it didn't. I got a warning at that point saying, whoa, this is an unsigned or untrusted script. I'm not running it. But never, don't fear. If you go to where you've unzipped your drivers and install those, which I'll show you now, there's a batch file that you can run. So this is where I've installed my Digistump drivers. I've extracted them into this one here, and I've run them initially installed drivers, which worked apart from one of them, but that didn't seem to have an effect. In fact, there seemed to be sort of a duplicate driver a bit further down. What it says is I can't run this post-install.bat because it's not trusted. So all I did was come here, run it again, which basically launches the same set of drivers. So if I run this now, you'll see exactly what I mean. Run this, it comes up and says, do you want to run it? Yes, I do. So that's the little batch file that popped up first. Then it says, do I want to run them? Let's run. Welcome to the installation wizard. That's thank you very much. Please wait. Now you see that first one there? Some of the drivers couldn't be installed, and it says Digistump LLC USB serial. If I expand that. Unfortunately, this window isn't expandable, so it sort of runs off. So that one says I couldn't do, the rest it could. And if you notice down here, there seems to be another one that was identical to the first one. Pretty much, I reckon. Ports and all that, yeah. So that one did install. So I think that the fact that the first one said, no, I'm not going to do it, I don't know, perhaps it's been superseded or something. But anyway, despite this error, it all worked. So just in case you come up with that, and if you get that post-install after the AVR boards have been installed, you might have to run this again manually. Okay, that was just a little, well, caveat really, a little gotcha. This is the one that makes your AT Tiny behave as though it was a keyboard. As you can see here, this is it. This is all the code there is. We have to use the DigiKeyboard H library, which is available from that site again, and I'll put a link in the video. What we're doing is here, that's basically initialize it as the comment here says. And then we're just going to say, hello Digispark. And then we have a little delay, and then it runs again. Now, just a word of warning here. Yes, of course I uploaded this, but having had experiences of nanos that wrote back to my keyboard, I was aware that it will write to it wherever your cursor happens to be. So if your cursor happens to be in the middle of your code, it will start writing here, hello Digispark, all over your code. So that's something to be aware of. If I just move the camera and show you that thing at the back, if you remember there was a video all about this where I have, well, I'm controlling this very video via this, which I still haven't updated. So if I press any of these, it sends a code back to Windows as though I'd press my keyboard to flip between different windows. So if I touch this one, for example, you'll see the workbench suddenly appear down below. I think, oh, all right, it's displaying the debug window at the moment. Let's take that back off. And this one makes me disappear. And back again. See, so this is already sending stuff back to Windows. And when I was testing that, I was having fun and games with it sending codes back to whatever window was currently in focus. So just beware about where you're sending those back to. So let's have a go at doing that. I'll get this prepared and tidy up this bench a little bit more, and then we can see what happens. Right, I'll just talk you through this. It's pretty simple, a little bit of circuitry actually. So we have our AT Tiny over there with our USB connections and P0 to P5. We're only going to use two of those. The plus, minus and ground are on the left there. Right, so the P1 will be output to an LED via a 150 ohm resistor, and P2 is brought high to plus 5 volts at 10k. That's the input pull-up effectively. And if you touch that to ground, it will start the flashing. Oh yeah, that's the LED. That's it. Right, that was a bit of fun and games getting all this set up, because I don't want it writing all this hello Digispark all over my code if I can avoid it, or my video setup or anything else. So first thing I'm going to do is take me off this video, because you don't need to see me, but you do need to see this behind me. This is Notepad here, which I'm hoping is going to be written to by this. When I plug this in down here, what you'll hear is a sort of kadunk, the old Windows USB sound, but nothing appears in the USB list that I can see, or it doesn't appear quick enough maybe. Because the way you program is that first of all you compile this and it will wait. Watch this space down here where the arrow is now, okay? Because what it will say is, okay, I've compiled, I'm waiting now to find a Digispark 85 or an AT Tiny85. Plug it in, you've got 60 seconds. And if you do it right, and we plug it in here quick enough, it'll go, yeah, that's fine, I found it. Because what happens is, every time you plug in an AT Tiny85, for 5 seconds, the chip waits for a programmer to connect. If after 5 seconds you haven't been successful in connecting here at the USB stage, then it says, oh, you didn't mean to upload any code then. I'll run the code that I've already got embedded within me. So that's what that does, which is why when you switch on one of these, even when it's all done and dusted, it still has this 5-second delay before things spring into life, and there's no way around that. That's just part of the bootloader that's been connected. So let's plug this in. I'm going to try and do this nice and quickly so that it doesn't start writing over everything. So first of all, compile, and watch this space down here. Okay, there we are. So it says plug in device now. So I will, excuse me while I just, oh, I knew the camera was going to get in the way. Right, there's the Windows sound, and it's found it, and there we are, look. So it's done it. Now I've got to put the cursor here. Oh, no. What did I say about it corrupting my program? Look, it's written over part of my program here before I put the cursor in here. Isn't that just typical? So let me just move this out. So what this is doing here, of course, is writing out what we've told it. DigiKeyboard dot println here. Hello Digispark. Oh no, it's writing it out there now because I moved the cursor. See what I mean? How dangerous this can be. Obviously, I'm not going to save this code now with these Hello Digisparks scattered throughout it, but it is writing something here. Now, what I haven't discovered yet, but hopefully I will do, is how to send extended window codes. That means pressing the Alt, Control and Shift keys, which obviously can be done because that's how my little video controller works. Because it's all very well sending messages like this, but this probably isn't normally how you do it. Certainly my video controller, the one I just showed you, sends a combination of something like Control, Alt and then a letter. So it's something unlikely to be used elsewhere. And I use that as a shortcut. So there we are though, without doing anything at all on here. So we've done nothing, have we? All we've done is plugged in the USB cable and it immediately identifies itself to Windows as some kind of USB HID, human interface device. And it accepts, or Windows accepts I should say, input. So this stuff being written to via this thing now, and the stuff you're watching in this window here, this is Windows now you're looking at. It's communicating via the USB port over here. Now as you can imagine, if you were to connect this inadvertently while you're programming, so you'd written some master program over here and you think, yeah, this is going to work on AT85. You plug in your USB port inadvertently without realizing you've got something like this silly program loaded, you're going to splat all over the top of it. So just be warned. Funny in this occasion, yes, but believe me, you will not see the funny side of it when you've written a very long piece of code and this starts putting these funny characters all in the middle of it. Don't ask me how I know that when I was writing my video controller. See, use my experience and pain to avoid it, that's what I say. Okay, so that's that. We might do another video this sometime in the future when I've discovered a few more things about it, but I was just bringing this to your attention, that it's a nice cheap little board, can do some things, but it is restricted in some ways because effectively you've sort of got 3 pins, haven't you? If, however, you don't want to program it via the USB port or are prepared to disconnect the pins down here whilst you program it, then you've got another 2. So that means 5. But I do want to put that pin extender on here sometime in the future. There's a library, a software library you can use with this. So you get software I2C, or I2C some people call it, or IIC in fact even. Anyway, I call it I2C as a lot of people do. If we can get I2C running on that with the pin extender, then the number of pins on here is almost irrelevant because we get another 8 or something on that pin extender. Okay, that's it. That's enough. We'll just say goodbye Digispark rather than hello. And I hope you found this useful. If you do, don't forget to share and give me a thumbs up. And thank you very much for watching. See you in the next video. I hope you're finding these videos useful and interesting. Please leave comments down below. Subscribe, share and give me a thumbs up. Thanks for watching. See you in the next video.